So the next application that I want to look at is system specification. So let's say that you have landed your dream job and you are now working on some really complicated piece of hardware or software, and your boss has given you, or maybe your team or you yourself have developed a whole list of specifications that are required for this piece of hardware or software. And usually these specifications are going to come in the form of a big old list of English statements. And they're things that maybe the client needs, that are needed for technical purposes, etc. But what you want to make sure is that all these different specifications of your specific system are consistent. That is, that they're actually going to work together. So system specification, being one application of propositional logic, is contained in Rosen section 1.2.3. And we can define it as follows. So a specification is a list of compound expressions, usually given in English, and it's consistent if the conjunctive, and remember the conjunctive is just a fancy word for and, of all the compound propositions is not a contradiction. And you remember the definition of contradiction, meaning that a compound expression is a contradiction if no matter the truth value of all the underlying variables, it's always false. So you want that not to be the case. Because if that is the case, then there's no way that all your specifications are going to be able to be satisfied simultaneously. So it's probably easiest to demonstrate this particular application using an example. So let's go ahead and say that you are designing some sort of system and that it's concerned about when a user interacts with the file system, when they save files, and when the system is being upgraded. So let's say that you have a specification, so a list of compound expressions that is given to you or that you have developed as follows. So here we have our specifications. We have a big old list of compound expressions. In fact, we have 3 different ones that are stated to us in English. And referring back to our previous video, you recall that we can translate this into propositional logic. And so we once again need to look for the different little phrases that will make us think in our mind of different propositional logic operators and help us figure out what we should define as our propositional variables. So here I see an if right there, and I see another if here and a cannot. I see an if that goes with this then right here. This little if right here, well, implicitly there's a then right there. I see a cannot here, and if I recall from implication, that whenever is another way that we can state implication. So I know that this is going to have to do something with implication. So looking at that makes me think that, well, my propositional variables might be the system is being upgraded, something about accessing the file system. Well, accessing the file system again, that's a good indication that that's going to be one of my propositional variables, as well as saving a file. Well, there's the system being upgraded, and another little word, not right here, that's going to be important, and saving a new file. So it really looks like right here that we have three underlying propositional variables that we need to define. So first off, system is being upgraded. So I'm going to go ahead and let that be U. Let's let U be the propositional variable that stands for the system is being upgraded. And then also accessing the file system right here. And lastly, we have this cannot save a new file right here. So I'm going to let S be So those are my three propositional variables that I am going to be using. And so with that, I can restate these English sentences into compound propositions by using the skills that I've learned from that previous video. So let's go ahead and do that now. So in particular, this very first compound expression right here, I could rewrite it in the following way. When the system is being upgraded, the user cannot access the file system. So I could represent that as, well, the system is being upgraded implies the user cannot access the file system right here. If the system is being upgraded, the user cannot access the file system. This second one right here, I could represent as follows. If the user can access the file system, then they can save a new file right here. So A implies S right here, or if A, then S. And then lastly, if a user cannot save a new file, then the system is not being upgraded. And initially, when you look at this, you might think, well, this is a weird bunch of specifications right here. If the user cannot save a new file, then the system is not being upgraded. Is this system specification right here actually consistent or not? Are there any truth values of these logical variables right here that will allow this system specification to actually be consistent or not? Well, by the definition of consistent right here, what I need to do is look at the conjunctive of all of these compound expressions right here. So the conjunctive of all of these compound expressions is going to be as follows. We have U implies not A, and So here I have the conjunctive of all of these compound expressions right here. And you can see that I have 3 underlying variables right here. So if I wanted to, what I would have to do is figure out U, A, and S. Draw myself a nice big old truth table like this and make sure that it is not a contradiction. And remember, a contradiction would mean that we have all falses right here. So this would be tedious to go through and have to fill out all of these different truth values right here. So let's see if we can't figure out some values of U, A, and S that would make this thing be true, at least in one instance. Because if we can make it true at least in one instance, then it's not a contradiction. Well, let's think about it real quick. So let's go ahead and, for the fun of it, make U be false. And the reason why I'm going to do that is because I know this implication right here. The only time the implication is false is when the hypothesis is true and the conclusion is false. And I'm going to make this A right here also false, because once again, I know that in this implication, the only time that it's going to be false is when the hypothesis is true and the conclusion is false. And lastly, for that S right there, I'm going to make that a true. So if I were to do that, then what would we get? So we have a whole bunch of other possible truth values of all of these guys here, a whole bunch of other truth values here and here, etc. But let's go ahead and see what would happen if I went ahead and used U is false, A is false, and S is true. Well, this proposition right here would become false implies, and not a false implies true. Oh, well, I know that thing is a true statement by definition of implication. And if A is false and S is true, well, once again, by the definition of implication, I know that this thing is true. And over here, I have not S, so that would be a, well, that would be a not true, so that would be a false right there. Implies not U, which is going to be logically equivalent to false implies true, which, yay, by the definition of implication right here, is a true statement. So in this particular instance, when U is false, A is false, and S is true, I know that this first compound expression is going to be true. I know that this second compound proposition right here is also going to be true. And I know that this third compound proposition right here is also going to be true. And I have a true and a true and a true and a true, and then everything becomes a true right here. And because I have at least one true right here, I know that this thing is not a contradiction. And because of that, I can say that therefore this thing is not a contradiction. Therefore, this system specification is consistent. So there we go. We've been given a system specification, we've translated it into compound propositions, and we have discovered that the conjunctive of all of these compound expressions is not a contradiction. Therefore, yeah, you could design a system that satisfies those particular specifications that you have been given right up there.